Okay. So we are multiplying and dividing rational expressions today, which are basically just fractions, except the fractions, rather than just a single coefficient in there, you have polynomials in there. So all those rules of fractions apply to rational expressions. And if you'll remember, when you first start learning about fractions, right, we always learn to multiply, divide before we add, subtract. Why is that?
Because that's the order of operations.
Well, but more than that, what happens when you add and subtract fractions?
They get bigger.
Okay.
They have to be the same denominator.
You have to have the same denominator, right? So if you are not able to multiply and divide, it's difficult to come up with the same denominator. So that's why we start with multiplying and dividing. Okay, so we want to remember the numerator and denominator should be non-zero polynomials. And a rational expression is considered fully simplified if the only common factor is +1 or -1, right? So it's just like I would never leave a fraction as 5/10, right? What would we do with it? 1/2. You would want to reduce it. So we do the same thing with the rational expressions. We reduce it. So this first example right in here, that's just kind of a basic, really what's happening here. If I have AB over AC, we can split that up into A over A times B over C. And that A over A, I know we often say they cancel each other. Well, they're just dividing out, because A divided by A equals 1. All right. Once you have 1 times, the only leftover part is B over C, so our final simplified form is B over C. Okay. Domain is very important with our rational expressions, because what is the one number you can never divide by? 0. So that's something we always have to pay attention to, because these are polynomials in there. We have variables. We have to always take into consideration what variables would make the denominator 0, and if it does, make sure that we make a statement about it. Oh, sorry, my screen is now frozen. There it goes. Moved too far though. Yes. Yes, Jane.
I'm just a little confused what the A over AB over AC.
This is just a.
Are you just splitting it up?
Yeah, just
multiply.
Well, splitting it up just to show that when you take that A over A, that A divided by A is just simply equal to 1.
Oh.
Right. So like I said, we often say like, oh, they cancel each other. They're not really canceling each other. One is being divided into the other to get 1. Yes, Molly?
Well, so it's like more like you're just taking like an A out of like the numerator and the denominator.
Yeah, so this is a very simplified version of what we're going to do, because we're going to be breaking down larger polynomials. Yes, Allison?
So does so I understand that A over A equals 1, but why does AB over AC equal 1? Because of the B and C.
Oh no, we replaced this A over A with 1. So we're left with just 1 times B over C.
Oh, and that equals B over C.
Just gives, yeah.
Oh.
Yeah, just gives us B over C. Okay. All right, so we are going to start with these 2 examples here. And you'll notice these are not solving for anything. It's just asking us to simplify the rational expression. All right, so if you'll notice, we've got quadratics. We've got 1 in the numerator and 1 in the denominator. And remember, we talked about this when we were learning to factor, how we want to get factoring down because we continue building on it. So here is one of those examples. So in my numerator, I have x squared minus 2x minus 3. The only hope of simplifying this expression any is if we can factor. And so that numerator will factor into x minus 3 and x plus 1. And what does that denominator factor into?
X minus 3
squared. No, not squared.
plus
Squared.
2.
There you go, x minus 3 and x plus 2. Okay, so now we've got this set up so that we've got 2 binomials in the numerator, 2 on the denominator, and everything is being multiplied. So remember, those binomials are individual terms, okay? And so it's basically 2 terms being multiplied in the numerator, 2 terms being multiplied in the denominator. And so what do we notice?
You can x minus 3 and x minus 3 are like the same term.
Exactly. And so I know we often like to say, well, they're going to cancel each other. But remember, what's happening is 1 is dividing out. And so x minus 3 over x minus 3 is 1. So those are now gone. And all that's left over is the x plus 1 over x plus 2. Okay. And remember, we have to take into consideration the domain. So I can look at this, our simplified expression, and I already know what can x not equal. Is it 0? Negative 2. I can see that it cannot be negative 2. Yes, because that would make the denominator equals 0.
And it can't be 0.
No, cannot be. So I can see that. However, because we divided a term out, it's no longer visible to me. And so I have to address the piece that I cannot see. So what was the term that we divided out? X minus 3. And what would x have to be to make x minus 3 equal 0? It would have to be 3. So I have to come back and make a statement that x cannot be equal to 3. Yes?
The x over x, you can't split that up because it's like attached to the 1 and 2. Right?
Exactly. Yeah. Okay, so this is our final simplified expression. Yes?
So why do you need to put that x can't equal 3 and not the negative 2? Is it just because that one's showing?
Yes. So is it okay to add cannot be negative 2? Yeah, you can write that if you want to, but you don't have to because anybody looking at the problem can see it. Yes.
So you do 3 because in the step before you had x.
Mm-hmm. It's simplified out. I can't see it anymore. But with the original problem, the way it is, you cannot have 3 in there or you would have no solution.
Because it would make the denominator 0.
It would make the original denominator 0. Yeah.
So you have to put that just because you can't see it anymore.
Yes. Yep. Have to make a statement about it.
Implied that you can't do.
Yes. Yeah. And again, it's okay to list the negative 2 if you want. It doesn't hurt anything, but you don't have to because it's visible there. Okay. Let's look at our next one. I've got 3m squared minus 48 all over 3 times m plus 4. All right, so I look at my numerator, and what do we notice we can factor out? A 3 comes out, so that's going to give us 3 times m squared minus 16 all over 3 times m plus 4. Okay, now what stands out?
You can divide it by 3.
Okay, so we can see that the 3's will divide out, so we can get rid of those. Anything else? Difference of 2 squares, which means we can factor further. So that m squared minus 16 will factor into m plus 4, m minus 4, all over m plus 4. And now what do we notice?
M plus 4.
M plus 4 over m plus 4. Those will divide out, so those are now gone. And our final simplified expression is only m minus 4.
You also put in cannot equal negative 4.
Yes, you do. And again, We can't see it anymore, but it is in the original statement or in the original expression, so we have to address it. M cannot be equal to -4. So any questions on those two? Okay, I've got 3 for you guys to try. All right, so I'll give you guys a couple minutes to work on those. Okay, so let's look at the first one. What's our final answer?
X over 2x plus 1.
X over 2x plus 1, and x cannot be equal to 2. Okay. Alrighty. D is a little bit trickier. Okay.
I thought that one was way easier than the other one.
You thought that one was easier? Well, the initial factoring is, because what is it you did first on this one? Take out the 2. And so that leaves you with x squared minus 25 over 5 minus x. And then you would notice that you've got a difference of 2 squares. So you would do x plus 5. Whoops. Why is it not?
Oh my gosh.
X minus 5. And then we're looking at 5 minus x.
Yeah, I canceled
Okay.
it as if it was x minus 5.
Okay.
I told y'all.
What do you have to do first?
It's not, I don't know, but I know that's
You
not it.
divide by -1.
Okay. So because there's 2 that are very similar to one another, but the signs are opposite, what we're going to do is factor a -1 out of this denominator. Okay. Which means that's going to change this to a negative and that to a positive. Okay. I'll rewrite it so it doesn't look so messy. So we get x plus 5, x minus 5, and again, the denominator is now going to be x minus 5 with a -1 in the front.
Wait, how could you just change? Oh, it's the same value, you're just moving it?
Yes, I just factored a -1 out. That's all I did. So now my x minus 5s do match, which means I can simplify. Do we want to leave a -1 in a denominator? No, we don't. So we're just going to move that -1 up, and we're left with -2 times x plus 5. And again, in the original problem, we had a 5 minus x in the denominator, which means what can x not be? 5.
Wasn't that changed to x minus 5 then? Or oh, in the original?
Yes, always refer to the original.
Well, that's first.
Okay. All right. So any questions? So this kind of goes back to, remember I said it's fully simplified when the factor is positive or -1. In this case, we had to get that negative. Okay. And our last one, I think that one was the easiest one of the bunch. What do we get? 1 over a plus 1. And is there anything a cannot be? Okay. Yeah, -1 also, but again, do we have to write the -1? No, we don't, but we can. It's not going to hurt anything. Okay, so that was simplifying. And now we're going to get into multiplying. All right, our first example, you guys have already been doing these. Okay. So just kind of a reminder of when you are multiplying any kind of fraction, really. Do we want to make terms larger and then have to simplify big numbers? No, you simplify in the beginning. Okay, so before, again, this is just 2 fractions being multiplied by each other. So it's the numerator times numerator over the denominator times denominator. But again, I don't want to create big numbers because the larger numbers are harder to simplify. So I'm going to simplify before I start multiplying. So I see a 6 and 9 in the numerator, a 3 and 2 in the denominator, and I'm like, well, that's nice because 3,
So, and
Crossways, right?
yes.
Like, what's it, like the
Yep.
butterfly way or whatever? Like that.
why do you do that?
Like where you circle. And it's
Because 3, I know 3 goes into 9 evenly.
But like, why do you do it like
Cross
that?
multiply.
This isn't cross multiplying. I am doing, remember, this is what happens here because this is just a straightforward multiplication. This is all just going to go together.
When do you cross multiply? I don't even remember that. I don't know why I said that.
That's when you have like two fractions equal to each other and you're trying to solve for a variable. Yeah, so if you had something like, you know, x over 2 is equal to 5 over 4, that's when you would cross multiply. Okay. Alrighty. Again, I want to keep simplifying. I also see that I have a 6 and a 2, which means 2 goes into 6 how many times? 3 times.
Ew, I did not like that.
All right.
Why did that literally confuse me?
I'm going to keep going here. I see over here I have an x in my denominator and an x squared in the numerator, so I'm going to divide one of those out. That's going to leave me with an x to the first here. And I also see that I have a single y here and a single y here, so I'm going to divide that out. And what's the last thing we can simplify?
The y's like the y2 and the y2.
Yes. If I have y squared in the numerator, and I divide that out with 2 of the y's in the denominator, how many y's am I left with? Just 1. Okay, I've got nothing left to simplify, so now I am going to go ahead and multiply across. I have 3 times 3 in the numerator, which is 9.
Wait, what about the x squared?
Yep, still going to get that. I have an x to the first times x to the 5th, so that's going to give me x to the 6th. All over, what do I have in the denominator? Just y. Question, Caraday?
Why? So you know how for like the diagonal y's in purple you cancel those out and that diagonal y's in blue canceled out. Why did you cancel out the x's on top of it? Like the green? Why didn't you cancel the denominator x on the left?
You could have.
Oh
Yeah. It's just that those happen to be right on top. The reason I did the y's was because they were both y to the first.
Oh.
So it was just easier to divide those out. Okay. Again, refer to the original problem. What variables did we have in the original problem?
X, Y.
We had x and y, and which of those are in the denominator?
Y.
Just y? The original. X was also in the original denominator, and right now it's not here. I know that y can't be 0 because I can see it, but I don't know about x, so I do need to make a statement that x cannot be equal to 0. Okay. So we're basically going to do the same thing that we just did, except we've got rational expressions to start with that we're going to factor out though. All right, so again, I don't want to multiply m plus 3 times 20m squared because I'm just going to create a much larger problem. Same thing with the denominator. I don't want to distribute that 5m to that quadratic because, again, creates a much larger problem. So I'm going to start by rewriting things in the factored form. So starting with m plus 3, that cannot be simplified, so I'm going to just rewrite it as m plus 3. Okay, I have 20m squared. That cannot be simplified, so I'm just going to rewrite it as 20m squared. My denominator, 5m cannot be simplified, so I will keep that as 5m. And now I have m squared plus 8m plus 15. Can we factor that? Yes. And that's going to factor into m plus 5 and m plus 3. All right. And now is the time we can start cleaning up. What do we notice we have in common? M plus 3's are in common, so we will divide those out. What else? 5 goes into 20 4 times.
How can you do that? Because they don't have the same m squared. Like one is m squared and one is m. I thought.
It's just being multiplied.
Yeah, because everything's being multiplied.
Oh, you can also take the n out of m squared.
Yes, we can. That's the last one we can do. I have m here, and if I divide it in there, how many m's are left? Just one. M to the first. Okay, so now I can clean all of this up. In my numerator, I'm only left with 4m. And in my denominator, what's left over? M plus 5. So I can look at this and I know that m cannot be negative 5. However, we simplified other terms out. So also cannot be 0 and negative 3. Exactly.
Wait, but there's only one variable, I thought. So why can it not be negative 3?
Oh, because you can't divide 0 by anything. So
Well, 0 can be divided, but we can't have 0 in the denominator. So again, remember the original? In the original problem, we have this m over here, and it's by itself, which means that m cannot be equal to 0. And then when we factored down here, that piece simplified out. So anything that would make m plus 3 equal to 0 has to also be taken out. Okay, any questions so far? All right. There's another one. Okay, so I've got here 3x plus 15 over 4 times 2x squared plus 11x plus 12 times 2x plus 3. All right, what happens when you are trying to multiply a fraction? Say 3/4 times 2. What do?
You put it over 1.
Exactly. We do the exact same thing with the rational expression. I'm just going to put that over a 1 to start. Okay, and again, I don't want to make things bigger. I want to reduce. So I'm going to start looking at what I can factor out. So I see 3x plus 15. What comes out of that? 3. And that leaves us with x plus 5. Okay, my denominator, I already have this 4 out here. And that quadratic here will factor into, does anybody already see it?
2x plus 3, x plus 4.
Okay. Does everybody see how she got that one?
No. Yes.
Okay, so remember, 2 is prime. So since 2 is prime, this first 2 here, we know that the first terms will have to be 2x and 1x. And then for the other 2 terms, we know that their product has to be 12. Okay, 3 times 4 is 12. And then you just kind of have to look here.
How does that equal 11?
Okay, the outer 2x times 4 is 8x. 3 times x is 3x. And when you add those together, what do you get? 11x. So that's how we know.
How did you get the 2x and x from just looking at 2x?
2 is prime. It can only be 2 and 1. It's just like 5. 5 can only be 1 and 5.
Okay.
Yeah, because it's prime. Okay, I still need to include my 2x plus 3, so I'm going to put that over here. Do I need to include that 1 anywhere? Nope, unnecessary. Okay, what can be simplified out at this point? 2x plus 3, we can simplify out. Alrighty, nothing else simplifies, so we're just going to rewrite what is left over. So we have 3 times x plus 5 all over 4 times x plus 4. Looking at this, I know that x cannot be negative 4. However, what else do I need to take into account?
It cannot be 0. It cannot be negative.
What's wrong with 0?
It can be 0.
0 is okay. There's no single
This
x.
is 12.
Mm-hmm.
But can it be 11
-1
times
negative
x at the beginning?
-1.5.
Or negative 3/2. Oh, sorry, cannot be.
What? Why?
Wait, can you just put negative
I thought you had to pull
1.5 or
it
do you
from the
want me to?
beginning to see if there's any more.
Well, we did. So remember, we factored it into this. X plus 4 is still here, so we don't have to include that. But the other one is 2x plus 3. So we know that 2x plus 3 cannot be equal to 0. And when we solve, that means that x cannot be negative 3/2.
Wait, would it be wrong if we put negative 1.5?
It's not wrong, but it's better to use fractions. Okay. Question, Allison?
How did you get negative 3/2 from that, though?
Oh, I just did this. This part here.
But 2x plus 3 was on the top.
Well, remember when we factored this, it was also on the bottom. And that's what we're going off of. What was on the bottom.
What about at the beginning?
What do you mean?
Oh, okay, because it's the factory.
Mm-hmm. Yeah.
Okay.
Yep. Okay. Yes.
You have to write both of those, right? You only have to write x not equal to negative 3/2. You don't have to write the 2x plus 3. It can't be 0.
No, you would, because you want to specify what x cannot be. Yeah, so this is the only part you need. I was just showing why we got the negative 3/2. Okay, here are a couple for you guys to try. All right, what did we get for D?
4x squared over x minus 6. X cannot be negative 6 or negative 6.
Yay! Guys are so awesome. Okay, wasn't E kind of fun?
Oh, yeah.
Got it wrong?
I mean, I would have described it as fun.
Okay, which part?
I got it all wrong.
All wrong? Okay, so let's talk about factoring. The first one, x squared minus 4x minus 21. What does that factor into?
X plus 7, x minus 3.
X plus, is it plus 7 minus 3? It's minus 7 x plus 3.
Oh, yeah.
Okay, and the denominator, we can take out a 3x, and that leaves us with x plus 2. All right. And for our other numerator, what can we factor out? X, and what's left?
X plus 8.
X plus 8. And for our other denominator, what does that factor into?
X plus 8, x plus 3.
X plus 8 and x plus 3. Y'all, when you are doing these, your favorite thing is going to be the dividing out part. We have an x here and an x here. We have x plus 8, x plus 8, x plus 3, x plus 3. And in the end, we are left with this very nice, simple x minus 7 over 3 times x plus 2.
On the outside of the x plus 8 go.
I divided it with the x that we factored out down here.
Oh, by the 3, okay.
Okay, and we eliminated a lot of pieces, so x cannot be 0,
Negative 3.
negative 8, or negative 3. Negative 2 is correct, except you don't have to list it because we can still see it. But it's okay if you do list it. No big deal.
Miss Dickinson?
Yes.
Are we gonna get anything back today, like the problem?
Not the problem sets, but the that extra practice for quiz makeup you will.
Oh.
Wait, what?
You guys had that extra worksheet that we did? Okay. So now let's talk about dividing. All right. So let's think back. If I had 1 over 2 divided by 3 over 4, how would we do this problem?
Flip the second and then
You flip. Okay. This would turn into 1/2 times 4 over 3. And would we turn this into 4 over 6?
We would turn it into 2 over.
Would simplify first. 2 goes into 4 how many times? Twice. And now we're already simplified because the only thing that is left is 1 times 2 is 2 and 1 times 3 is 3. Okay, this is the same thing we're doing with our rational expressions. Okay. So I see that I am dividing. So before I flip that second one, I'm going to, when I'm setting it up for that, I'm going to factor at the same time. All right, so in our first one, I have 2a over a plus 3. Neither of those can be factored any further, so we're just going to rewrite them. 2a over a plus 3. All right, so that's the keep part. You guys remember that terminology, keep, change, flip? No?
what is the
Flip
song
the
that
second
is
and
like
multiply. That's what I know.
Okay.
Dividing, backwards dividing,
Okay.
Flip the second and multiply.
Well, I also learned keep, change, flip. Keep the first one, change division to multiplication, flip the next one. So when I go to flip the next one, a plus 3
It's on top.
is going to go on top, and it cannot be simplified, so it's going to stay as a plus 3. And the a plus 7 is going to move to the denominator, and it cannot be simplified either. So we just do this. Okay, if it helps, put the parentheses around so that you don't mix pieces up. And now what happens?
Cancel the a plus 3.
A plus 3 divides out, and we are left with 2a over a plus 7. Now, we want to keep in mind, what did we originally have in our denominator? A plus 3. So that means a cannot be negative 3. All right.
Only because a plus 3 was on the bottom. Right?
Yes, it was in the original one. Okay. Here's our next one. Fraction divided by non-fraction. What does that mean? And we're just going to put this over 1.
1 over it if you don't want to
Yeah.
rewrite it.
Okay. So I am going to have to rewrite again. I'm going to factor at the same time. 2m plus 6. What can we factor out?
2.
2. So factoring out the 2, I am left with m plus 3. M plus 5 cannot be simplified, so we'll leave that as m plus 5. Keep, change, division to multiplication, flip. So my numerator will now be 1, and my denominator will now be m plus 3. And now these will divide out, and we are left over with 2 over m plus 5. Okay, I already know that m can't be negative 5, but what do I not know? Yes, I don't know that one. M cannot be negative 3. Okay, pretty straightforward? Yeah. All right. So I've got 2 more for you guys to try, and then I've got some extra ones on the bottom if you feel like you need more practice, but we'll start with these 2. Okay, what did we get for C?
0.
X plus 3 over x. X cannot be equal to -2 or -3.
So interesting. You know me Oh,
Okay, and what do we get for D?
X 1 over x minus 1 cannot be equal to -2.
I never had
Not
that
be
on my-
-2 or 0. There we go.
Wait, from C, why did we put -3?
Because when you factored these two originally over here, you have x plus 2, x plus 3. So the original denominator.
Oh, okay.
Yep. Okay. You can write 0, but you don't have to because it's visible.
I didn't see.
Yeah. Okay. If you guys want some more practice, here are a few more you can do. Otherwise, you can get started on the homework or the extra practice for the test. Up to you. All right. So again, these are the final solutions for these 4 for anybody that wants to work through them. That's it.